Hello everyone, welcome to Homework Help. If you find the videos useful, please subscribe to the channel. So in this video, we'll solve this problem based on the concept of vectors as forces. So as per the problem, determine the resultant and equilibrant of each pair of forces acting on an object. So let's start with part A. So in part A, we are given force F1 that has a magnitude of 5 Newton acting due east, and F2 has a magnitude of 12 Newton acting due north. Now the first step here we should do is to identify the main directions, and they are east to the right side, west to the left, north in the upward direction, and south in the downward. Now we can draw these forces F1 and F2 based on the given directions. So F1 has a magnitude of 5 Newton due east. So this is F1. And then F2 has a magnitude of 12 Newton acting due north. So this vector is F2. Now we have to find the resultant and equilibrant for these two forces. Now these two vectors are perpendicular to each other because one of them is acting east, the other one is north, and east and north are perpendicular to each other. So the resultant of these two forces is the third side in this right angle triangle, which is also the hypotenuse of this right angle triangle. Now the length of this third side represents the magnitude of the resultant. So we can find the magnitude of the resultant or the length of the hypotenuse by using Pythagorean theorem. So our equation will be now we know that F1 has a magnitude of 5 newtons and F2 has a magnitude of 12 newtons. Now 5 square equals 25 and 12 square is 144. And their sum is 169, and we can apply square root to both sides. And square root of 169 is 13, and the unit is newtons. So that's the magnitude of the resultant of F1 and F2. Now we also have to find the direction of the resultant, and for that we have to find the measure of angle theta. So since it's a right angle triangle, we can use the tan ratio. So our step will be, and the formula for tan as per SOHCAHTOA is opposite over adjacent, and for angle theta the opposite side represents vector F2. So the magnitude of F2 over magnitude of F1. Now we can do the inverse of tan. Now we can use a calculator to evaluate it, and I got 67.4 degrees. So the resultant for F1 and F2 is, so we start with the magnitude, 13 newtons, and the direction, which is east, 67.4 degrees north. Now this direction can also be written the other way, from the north, and if we write it that way, so for that we'll have to do 90 degrees minus 67.4, and the other direction can be so 22.6 degrees east. So we do 90 minus 67.4, and that's how we get 22.6 degrees. Now equilibrant is a vector that has the same magnitude as the resultant but opposite direction. So the equilibrant vector is 13 Newton magnitude, and the direction will be opposite to that of the resultant, and that will be, so the opposite of east is west, and then 67.4 degrees, and the north changes to south. Or if you want to use the other angle, then it will be south, and then 22.6 degrees, then west. So we can write the answer using either direction. So this should be the final answer for part A. Now we can analyze part B. So we'll start with the diagram. So in part B, F1 has a magnitude of 9 Newton acting due west, and F2 has a magnitude of 12 Newton acting due south. So we have F1 going in the west direction, and F2 in the 12 Newton acting south. So we are placing the vectors tip to tail or head to tail. And these two vectors are perpendicular to each other because west and south directions are perpendicular to each other. So the resultant of these two forces will be the hypotenuse of this right angle triangle. So we have to find the length of this hypotenuse, and then we'll find the angle theta. So we'll use the Pythagorean theorem to find the magnitude of the resultant. Now we can sub in the values. So 81 plus 144 is equal to 225. And now we can apply square root to both sides. So the square root and the square get cancelled out. And square root of 225 is 15. And the unit is newtons. So this is the magnitude of the resultant. Now we can find the direction. So we have to find angle theta, and we can use the tan ratio because this is a right angle triangle. The formula for tan is opposite over adjacent, and the opposite side represents the magnitude of F2. So we can sub in the values. And now we can do the inverse of tan. Now we can use the calculator. And I got 53.1 degrees. So the resultant vector can be written as, so the magnitude is 15 newtons and the direction will be, so from west 53.1 degrees south. Now if we want to use the direction the other way, so the other direction can be written as south, and now we have to do 90 minus 53.1, which is equal to 36.9 degrees west. So this is the final answer for the resultant of F1 and F2. Now we can write the equilibrant. So the equilibrant vector will have the same magnitude as the resultant, but the direction will be opposite. So the opposite direction of west is east. The angle will be the same. And the opposite of south is north. But if you want to use the other angle, then it will be north, east. So this should be the final answer for the equilibrant for part B. So these are the steps you have to keep in mind to solve a problem like this one. So I hope you'll find this video useful. Please share it, like it, and subscribe to Homework Help. Thank you very much and have a nice day. Bye.